Hi, everybody, and welcome to the DevSecOps track. My name is Lars Lefevre, and I'm a volunteer at the OWASP community, and I'll be moderating this session. So during the next 45 minutes, we'll hear Lewis Denham Parry present the hand that feeds how to misuse Kubernetes. So please submit any questions you have during the session in the Q&A tab, and I'll be asking our speaker the questions in the last 10 minutes of the session. So let me introduce Lewis. Lewis orchestrates containers by day and hacks them by night. He has consulted in many roles, from developing software on bare metal to building the infrastructure in the cloud. He's the head of training at Control Plane, assisting others in understanding and implementing best practices, and has presented talks and workshops at numerous international conferences, from KubeCon, SANS, B-Sides to local meetups in Wales. Well, with that, I'll hand over the word to you, Lewis. Take it away.
Cheers, Lars. That's a great introduction. And it feels like I wrote that myself a while back. But yeah, thank you everyone for attending today. Hopefully you can see my screen as well. So I will be talking today about the hand that feeds, how to misuse Kubernetes. Now, whilst I've got your attention here, some of my favorite speakers that I've gone to, they start off with a slide that means a lot to them. I'm going to go into Kubernetes and how we can misuse it. But to begin with, I'd also like to just state that everybody belongs. I suffer with mental health issues. I've suffered from depression. And so I just want to take this opportunity just to say, if anyone else is in that same boat, you're not alone. Go find some resources. There's this great mental health hackers that I've met at a conference a couple of months ago in America. They do some great initiatives there. But yeah, and equally with this honesty aspect right now, I wasn't very well yesterday. And yeah, I understand that we've all been in this issue for the last couple of years, where the first, is it going to be that thing? And it isn't at the moment. I think it's food poisoning, which hasn't been great. So leading up to today, I was very anxious at about 2 a.m., 3 a.m., 4 a.m. this morning, as I couldn't sleep and I had a fever. So hopefully today, please, I'm going to try and take it a little bit slowly. Please ask some questions. I'm more than happy to do my best to answer them. I've currently got some great medication, which says that I shouldn't be operating heavy machinery. So I've taken my laptop instead of my tower to walk through today. So hopefully, fingers crossed, we'll get through this. But yeah, let's have a look. Now, this for me is what it's all about. This is my favorite slide that I've made for this talk. Now, the hand that feeds. Incidentally, if you're looking at getting into speaking, what I did and my creative process has been to attach to songs. And so this is a song by 9 Inch Nails called The Hand That Feeds. But that's what I think Kubernetes is. Kubernetes, we declare the state that we want to be running across our clusters. And then Kubernetes feeds us these workloads. And so we're dependent on that. But what happens when we bite the hand that feeds? How can we manipulate Kubernetes to be able to run workloads that might be malicious or might give us some pivot points and so forth? So even though I've had this introduction, I am Lewis. You can find me at Denham, Parry. I also work for Control Plane as a head of training. I would say that Control Plane first started off as curators of GIFs, and then we pivoted into DevSecOps. But as a company, we work in the cloud native space, and we work at securing it. So we do everything from consultancy to training to pen testing. If any of that is of interest to you, whether you want to jump on board or if you want to help us solve some difficult problems, then please drop me a message. And this is my branding slide for the company as well, Control Plane. So this was at another conference as well. We like just to have these talks. We like to talk about what we're doing and how we're doing things. And this was my marketing idea to put our flashy sticker outside the hotel. Now, you might already know some of us from our book, Hacking Kubernetes. So there's Andy and Michael. They were the core authors for that. It's available online in all your favorite bookstores, everywhere you want to go. You can get a free copy of it via that website. And in that book, it was a really great experience for us in that we put our best foot forward saying, right, this is what we deem to be attacking and defending Kubernetes. And we reached out to other people within the industry and they came back. And this really opened up our eyes as well. There's such great content in there. Now, usually the authors sign it. My name is in the book. So if you do purchase a book, if you see me in real life, I'm more than happy to highlight my name if you so wish. Now, as you've probably been aware, I've got some terrible dad jokes on the go. So we'll just do one last one. So could anyone tell me what this is? So we can see that there's someone going to a store there and there's another person. Now, this is a little bit difficult as well to do because at this moment in time, I think I can see the chat on my phone, but hopefully if this is not a line, incidentally. In the UK, we don't call this a line, we call it something else. So this is what I call Kubernetes. Now, yes, Kubernetes has been around for a while, and this is what we're going to be talking about today. And as I said, it's this basis of biting the hand that feeds. Now, as head of training, personally, I learn best by working with things. And when I say working, really, I mean breaking things and then fixing things. I'm very much a hands-on person. I really wish I could be the other way around, where I could read something and understand it, then I go into it. But in all honesty, I'm someone who I just want to hack away at something, break it, and then I read about it and fully understand it. So with our training, we do CTF exercises, capture the flags, which I assume you're aware of, but capture the flags for us, it's gamification of this learning. A little bit of a brief history for me. I started off as a web developer, as I was introduced by Lars, and security was a terrifying concept to me. The reason it terrified me is because I found it difficult how to know when I've done a good job. And if you just saw the previous threat modeling talk, well, that's one of the core things. How do we know we've done a good job? At this time, and linked to my mental health, I had to reevaluate what I was doing for my career. And I realized I like solving problems. Now, and problems are usually associated with puzzles, and that's what I feel this is. So with capture flags, they give us defined boundaries, and they give us puzzles that we can work with. So what we do at Control Plane is that we create capture flag competitions, but we also use them for training. And the basis of this is that if I teach you how to hack Kubernetes, I'm going to have your attention. And then if I have your attention, then we can talk about defending it. It's a lot easier for me to be able to attack and then figure out how to defend than the other way around. So with this is something that we do for a number of companies. If this is of interest to you, we've got a lot of backlog of scenarios that I'm more than happy to share with you. We've been doing this at Security Days KubeCon for the last 3 years now. We'll also be doing another CTF competition in Detroit later in this year. So if these are of interest to you, please reach out to me on whatever channel. It's quite easy to find me on my internet, on our internet, thanks to my surname. There's only one Lewis and Parry at this moment in time. So please feel free to reach out, and I'm more than happy to send you some credentials over an unsecured path to give you these SSH credentials, and then you can attack some clusters. So let's just have a look here. This is the MITRE attack framework by Microsoft, looking into some of the techniques for hacking or attacking Kubernetes. I'm not expecting you to go through all of these, but it is a great resource to use to understand what we have. Now, Kubernetes is on a 4-month release cycle, so every year there's 3 new releases. The point that I'm trying to make here is that we can see depreciated techniques, and there's new techniques coming each time. So we're going to go through a couple of these today, and we're going to do a CTF together. So I'm going to show you one of our scenarios that we do, and hopefully we can just hack together. So hopefully you can sit back, relax, yeah, I'll try and keep the chat available on my phone. So if you do have questions, please feel free to shout them out and go from there. Cool. So section 0, always start with 0, our DIY bug bounty program. Now, hopefully this is the beauty of virtual conferences. It's never a case of, okay, at the back of your room, can you hear me? Or can you see my screen okay? It's like, cool. Hopefully you can see my shared screen. Otherwise, this is going to suck for the next half hour or so.
Yeah,
but
I see it.
This was cheers, Lars. Thanks, mate. So this was one of the CTF scenarios. This was our introduction scenario that we did for KubeCon North America 21. The conference was based in LA, so we took a concept of Hollywood. So our CTF exercises were based on film. As we go through the CTF challenge, we'll look more as into this influence from film. But here, what we can see from our website is that we've got a memory CI/CD build system where experiences become memories. Which movie could this be? So let me just switch my mouse to my laptop. There we go. So I can check the build status. And you can tell this was probably made by myself because the build system is currently down, which isn't ideal. Also, why is this publicly facing on the internet? Now, so we've had a look at build status. We can see that it's down. If we look at our utilities, then this to me looks like it's offering some help for sysadmins to look into what's happening with our service. Now, with our utilities, I can see that we have a ping address there. So I don't want to use 1Password. There we go. So I'm just going to ping 1.1.1.1, and I'll submit this. If we can see there, it's prepended with ping -c3, and we can see that we get the response back from the website. Now, this is interesting for me, and hopefully this might be of interest to you, especially at the OWASP conference. What might have happened there? So if we have a look here, so I've pulled up the developer tools. Again, I'm using Chrome at this moment in time, whichever browser you should be able to follow along with and do this. So if I just refresh this page, I can see that I've got a diagnostics PHP command. Now, this is a beautiful thing that I have here. If I right click on this and I click copy and copy as curl, I can go to my terminal. And in my terminal, I can paste this, and there is a lot that has been pasted in there. But if I hit enter, then I can see the HTML response from this website. Again, this is probably why I'm no longer a front-end developer, by the way. If you're looking at the website, personally, I think it works really well. I think it's clean and clear and concise, but yes. So I can see the HTML response there. So let's have a look back at this. My previous command, for some reason, isn't there. There we go. So here we can see what we're sending across. So let's just do a quick test here. And again, I'm sorry for the amount of information. It does become clearer in a moment. I swear we will make things always try harder. But to begin with, we're just going to try our proof of concept. So instead of doing the ping and then it's HTML encoded, I'm just going to run who am I. So with this, I get a response from a website, but this time I can see that I'm Nginx. So this is allowing me to do an injection attack on a website where I can run some commands. And so doing an ls, I can list the files that I have in the current working directory. So this is my point of entry into the system. And this is what we're going to do for our attack. So our attack in this instance, what we're going to attempt to do is create a reverse shell. So instead of me having to constantly do this, I'm going to try harder and I'm going to make it easier for me to be able to access this website. So there are going to be a couple of things that we do to achieve this. Now, first of all, I hope you love Bash. I absolutely love Bash. It's it's everywhere. It runs everything. So I'm just going to change this to double quotes now, because what I'm going to do is I'm going to put in $1. So I need it ping equal though. So in doing the double quotes, then instead of having single quotes are literal. So that would essentially be sending across $1 to the website. But what I'm trying to do is I'm trying to prepare my payload. So I'm not expecting anything to work here. And it does show a lovely PHP error. Again, giving me some information as to what's potentially going on there. Now, here we go. This is where, with all the medication I'm currently on to try and keep going, trying to pair up on the interwebs right now. So the command that I'm going for is that I'm creating a bash function called exec. And then in the exec function, I'm just going to take through what I previously created there. And the bang bang, the 2 exclamation marks, that's just going to be replaced with the previous command that we ran. So if I run that, I don't get a response. But now what I can do is I can run exec who am I? And now I get the response from the website. So instead of me having to go back through that curl command that was provided from the website, this time I've just made it a bit better. So I can just do exec ls. Or I can do exec, if I do in double quotes, exec LSLA, then this is giving me some information back. So again, we're starting to get information out of this website, but we can do better. We can make this experience a little bit easier for us, and that's why we want to use this reverse shell. So I'm using something locally on my terminal called TMUX, that's Terminal Multiplexer. If this is the first time you've seen this, definitely have a look into this. TMUX is just invaluable to be able to get these functions across. So I guess I should ask in the chat, but do people use ngrok? So usually people use ngrok to share, say, a website or something that they're developing on their local machine so that they can share a port onto their local machine publicly on the internet. Now I'm just preparing our attack, and so at the moment in time I am at my house, which is a luxury. Sometimes when I deliver this talk, I'm on a personal hotspot or on someone else's Wi-Fi network. So using ngrok, it gives me this public endpoint, 0.tcp.ngrok.io 19 on port 19843. And any traffic that's received on that will go to my local host on port 31337. Now here, I'm looking at you here now. There's an element of trust with this. Please don't DDoS, but please be kind for the next half hour so we can go through this, because we got 3 levels of attacks here. If you start hitting that, then it's going to suck for me, and I don't think I've got enough water in me to be able to cry today. So so we've got this port available. Now there's a tool that I like to use. So some people use Netcat, but there's this tool called Penelope, and I'll share a link into it in the slides in a moment. So Penelope it's like Netcat, but with emojis. It manages these reverse shell sessions for us. So what's happening now is it's using Penelope, and I've given port 31337 on my local machine. Penelope is waiting for any traffic that is coming to that port. Now we want to go back to our onto our hack. So let me just quickly check. So we just got to remember this part. Let's just copy past of this. I swear, sometimes I do type a little bit faster. I'm just leaving that in my history just for a moment. So let's try this then. Let's try an exec, and we're going to run ncat. Now we're going to run ncat on that website that we're looking that we're attacking. So we're going to use ncat, and then we're going to use bin shell, and we're going to use v-n, and we want to use that previous. Now I'm going to have to edit this a little bit, because I don't want to have a colon there. So I'm running ncat, and it's going to attempt to connect onto 0.tcp.ngrok.io on 19843. Now remember, then when that's received on the public internet, that's going to then tunnel it through onto my local host on port 31337. So we've got a little bit of an issue here in that we can see that the name does not resolve. So we can either quit and get half an hour back to your days, or we'll try a little bit harder. So what I'm going to do is, hopefully I've still got this in my paste, yes, we do. So I'm just going to dig on this, and I can see the IP address associated, the A record associated to 0.tcp.ngrok. So what we're going to do is, we're going to replace the DNS entry just with the IP address. Because if it can't resolve a DNS entry, well, it can hopefully resolve an IP address. So if I run this now, nothing is happening, but let's go and have a look. Hopefully in here. Ah, yes, we can see. So Penelope has got a reverse shell, and it's assigned it to session ID 1. Again, Penelope is a great tool, definitely recommend it. And I say all this, it's mainly the emojis as well. Like anything with emojis, I'm all in. Maybe I shouldn't admit that. Maybe that's one of the weaknesses of myself I should not admit. But now that I've got this reverse shell, so I can do an ls, I can do an lsla. Yeah, and so the point as to what we've achieved here is that instead of us having to go back and do our hack to be able to, let me just get back onto this. Instead of us having to use our hack, that should still be fine. When we started off and we had this huge, huge call request, we've tried harder. made it to a position where we can just run it as if it was on our local machine. And so I've got reverse shell available there. So this is my entry point now into this website and wherever this website is running. This isn't, incidentally, isn't to do anything with Kubernetes at this point, but this is just showing an attack that can happen. One of the feedbacks that we took from our CTF challenges used to be that, well, you give me SSH credentials. So if you give me SSH credentials, then I'm fine. I just don't give anyone SSH credentials to my clusters, which, again, great practice. But we wanted to show this attack and how we can mitigate it. So let's just go back to our slide decks for a sec. So what did we do? We opened up this back door and we are able to get into the website. So we identified an injection exploit on our CI/CD website. So remember our website where memories are made. And we managed to run the shell commands via curl. Now doing that from the terminal, we were able to start playing about with that. And then we set up a reverse shell using ngrok and Penelope. Other tools are available, but that's what we've done here. And I think we can all agree, as I alluded to earlier on, this one is a job done well so far. So if ngrok is new for you, then please have a look there and also look at Penelope too as well. Now, this won't be a security talk without talking about how do we prevent this? Well, OWASP best practices, the reason you're at this conference today. We shouldn't be able to send a request to a website and be able to remotely run commands within wherever it's running. So from a container perspective, we want to limit the tools within the image. So for example, we don't necessarily need to have bash in there. We don't need to have a shell in there potentially. And again, you probably heard more about this in a threat modeling talk previously. If we've got public workloads, because at the end of the day, we're on the internet, we need to have some public facing workloads. Do a threat model, like have a look into, do we really need to have bash there? Can we build this architecture to create security in depth so that this reverse shell couldn't have happened? Ultimately as well, this could just be a bit of a nightmare for you. Or sometimes, I know this isn't helpful for anyone, but we could just turn off all the computers and we could just go back and live a happy life without having to moan about computers. So we're going to go for a little bit of a speed run in Kubernetes. Now, to do this speed run, I'm going to go back to our reverse shell. So I'm just, now that I've landed in here, and again, I'm sure if you're a pen tester, you're probably screaming at me right now saying, well, IDS, it's, yeah, I get that. But again, this is for us, this is our learning tool. This is a way to get you thinking about Kubernetes. So once I land in here, I might start to try to find out some information as to what I have available to me. So I can look at our environment variables. There's nothing too much available to us there. I could look at the processes that we have running. So I can see, like, this is listing all processes. I can see that there's an Nginx worker process. The master is PID1, so that's the core process that is running. We can also see where we ran our ncat from earlier on in the shell. And Python 3 there, that's Penelope just upgrading our experience. And finally, on process 88 is our PS orgs that we just ran there. I could look at DF and see what we have available. Now, there's some smells here already to start saying to me, well, I'm running Kubernetes, because I can see that there is a service account mounted. We'll come back to that in a moment. But let's have a look. Let's see if we can have a look at our mounts. Now, I don't have any mounts available, but remember, if we have a look at our PS orgs, we got process 1 available to us. And if we go into our proc, and if I do ls, so each of these each of these numbers here are associated with the PIDs up here. So if we go into 1, and here, here I can see a number of things available. So for example, if I cat out the command line, let's see if we can get that. We can see the initial command that was run for this process, but the file that I'm interested in is mounts. So if I cat out mounts, then even though the mount command wasn't working, I'm still able to see the mounts that we have available. So then using the tools that I might have disposal. So if I grep and Kubernetes, spelled it first time, again, I can see here the temporary file system that we have running with our service account. let's have a look as well. So tempfs. So we're looking at temporary file systems, and we've got a couple of things here. I say a couple of things. What am I looking for? This is always a point when I panic because, yeah, we'll come into that now. So Kubernetes, when we run Kubernetes, there's this concept of config maps and secrets. So config maps and secrets are essentially the environment variables or parameters or files that we'd be putting into our application. And so with Kubernetes, when we create a config map or a secret, then it's held as a temporary file system within the container. So it's mounted in there. So this is the reason I'm looking for this is because these files, if they're mounted into this container, then that's probably points of interest for me to look into, and I'll have some value there. So let's just see if we got run emotional status. So I should be able to see emotional status up there again, like, oh, yeah, it's somewhere there. Again, apologies, I'm so rough right now. So I can see emotional statuses. And so if I cut out the emotional status, it's because I'm not in that directory, am I? Emotional status current. I can see anger, fear, and disgust. So let's just replay that command and we'll append that with an echo so we get onto a new line. So anger, fear, disgust. Now, let's see if anyone can. So you don't need to know about Kubernetes for this point. What movie is this related to? So if in the chat or anything, if you can figure out the movie that this is related to, that would really help out. So whilst we do that now, we're just going to have a look into our Kubernetes. So kubectl version. So kubectl is a binary, and what that does is it connects onto our Kubernetes cluster. We've got some slides to show you what a Kubernetes cluster is in a moment. But I can see here, I've got a couple of warnings. But I can see the connection to server localhost 8080 was refused. So even though I got the binary available, I don't have access to the cluster because I'm not authenticating myself. I'm not using a token. Now, if you remember, we did have a service account. So how are we doing on time? Okay, we might just speed run this bit a little. But let's have a look at our service account. So let's go cd var run secrets Kubernetes. And then let's go into our service account. Now here we've got our cert, we got a namespace and a token. So let's have a look at our namespace. So we're currently in CI memories, and let's cat out our token. So in catting out our token, to me, that looks like a jot. And so what that's going to do is that's going to authenticate my, I can use the service account to be able to authenticate against a Kubernetes API. If I can authenticate against a Kubernetes API, I might be able to run some workloads. So at this point, I'm going to blame it on the sickness, but I'm just going to do a copy paste. Here's the command that I ran earlier, but we'll talk through it here. So we've got kubectl -- server equals https kubernetes.default.@service.cluster.local. So fun fact, Kubernetes runs its own DNS, and that's what we use to be able to communicate within our cluster. So we can assume that this is within our cluster, so it's going to connect onto our Kubernetes service, our Kubernetes API. Then I can pass through a token. So I'm going to cat out var run secrets Kubernetes IO service account token. Finally, I don't care if it's insecure right now, so I'm going to pass through to skip the TLS verify, and then I'm going to request version. So if I do that, I can now see that I'm getting a server version response. So that's gone from trying to do kubectl version. Because a kube config file hasn't been set, if I run this command and I pass through the server that I want to connect onto the token that I have, then it gives me a response from the server. Now, as you've already figured out, I'm a bit lazy, and so I want to make things easier for me. So I don't want to keep having to go back to this, so we're going to create an alias for a moment. This is where I panicked when I tried to remember how to spell alias. Shout out to everyone who's dyslexic out there. So sometimes with Kubernetes, I forgot forgotten the chap's name now, but there is a really good resource to be able to get these aliases for some really good Kubernetes aliases. So now if I just do k version, so instead of me having to replay that command, I can just do k. So I can do k get pods. Oh, that's forbidden. So maybe let's have a look at services. So pods are a concept within Kubernetes. So pods are essentially containers that we have running in as our workloads. So I don't want to use kubectl. I want to use k. I want to use my alias k get service. I'm getting an error from server is forbidden. So even though this is an error, this isn't a bad error. This is just telling me you're not allowed to do this. And this is because we're using role-based access control. So with role-based access control, or RBAC, we can define what a service account or a user has access to. So this service account, for instance, I'm not able to, the service account in it can't, called MindReader, it can't look at services in the namespace default. Now, there's this beautiful command that I first learned from Duffy. I've got Duffy's Twitter handle later on in the talk. But what we can do is I can do kubectl, can I get pods? No. Can I get service? No. That's great, but I just want to do the Hail Mary on this and just tell me everything that I can and can't do. So if I do -- list, then it shows me all the things that I can and can't do with this service account. Now, Ian Coldwater as well, they've got a great quote. We're all made of stars, but your RBAC shouldn't be. If you're seeing stars everywhere at this point in time, it means that you're cluster admin. And that's a great day for you if you're looking at trying to utilize this cluster, but it's a bad day for anyone else who's trying to defend this cluster. If you can do absolutely everything, then you can run workloads anywhere across your estate. You could do a denial of wallet attack. You could spin up some crypto miners if people are still doing crypto mining. I'm sure they are. So that's a bad day. Now, but again, we want to try harder. Now, if we can remember, actually just trying to remember where we are. How ironic. PWD. Okay, so I am in service account. So if I do an ls, so remember, we had this file called namespace, and we can see that it says CI memories. So namespaces within Kubernetes, it's a virtualization technique to run, say, a virtual cluster. So what do I mean by that? Well, if you're running a cluster, we can use namespaces to run independent workloads. So a namespace might have a name, say, as production, staging. It could be developers, it could be Lewis, it could be whatever you want it to be. It could be CI/CD. In this instance, we've got CI memories. So if we go back to our command of when we try to kubectl get service, this is saying that we can't do this command within the namespace default. So default is a default namespace that's created by Kubernetes. So if we can't do that within default, then maybe let's have a look at what we can do, but within CI memories. So let's k off, can I list? Okay, a off, can I list? If I go back here and I'm going to do -n CI -memories. So now I'm stating that, well, I wanted to see what I can and can't do within CI memories. Now within here, I can see that there's one subtle difference. I can do things with config maps. Okay, so I'm going to look at the chat. I don't think there's much chat on the go. That's totally cool. I get it. I said you to sit back, relax, so I wasn't expecting any chat there. Let's remember our emotional status. So anger, fear, disgust. Now, hopefully you're shouting the movie to me, which is Inside Out, the beautiful movie about memories and how they're managed. But there are two emotions that are missing here. Ironically, right now, joy and sadness is, well, I'm still always looking for joy. So let's have a look. Maybe if we just, let's see if we can change this file. So I'm going to use Vim because obviously we've got Vim in here. So I'm going to add joy and sadness. I'm going to save it, but the file is read-only. Now, that file is read-only because it's a config map. This is Kubernetes. It's putting this config map into our container, And by default, it's setting it to read only, because if we're using a config map, well, this is some better practice. We don't want to have it overwritten, because this is what's affecting our application. This is what we have running. So we don't really want to edit it in within here. But remember about this title of the talk, misusing Kubernetes, biting the hand that feeds. Let's see what we can potentially do. So if we go back to our command here that we had earlier on, our alias k. So what we've done this time is that we've added on to our namespace of CI memories. So now that I've got CI memories, I can just do get config maps. And I can see the config maps that I have available within this namespace. And I can see that there's emotions there. So if I output, so let's get emotions. We don't care about the root cert at the moment. I do care about spelling emotions correctly. And I output it as YAML. I can see here that the current emotions are anger, fear, and disgust. Now, if you remember with our auth can I list, so config maps, I can get list, patch, and update. So I'm going to do a k edit. Eventually, he spells edit. Config maps. Let's just clear the screen for config maps emotions. So now using kubectl, I'm able to just get the YAML back. It's opened it up in Vim for me, which I'm happy with. So I can do joy, sadness. And then just for me, because just going to add it in here as well. So now I'm going to save that file. And we can see that we get a response. So this is coming from kubectl to say our config map emotions has been edited. So let's replay a command that we had earlier on. Our emotions output is YAML. So we can see our current emotions are now joy, sadness, anger, fear, and disgust. Now we've updated the config map within something called etcd, which is the state store within Kubernetes. We'll have a look at that in the slides in a moment. Now, this sometimes could take a little bit of time. So let's have a look at our run, emotional statuses, current emotions. There we go. So now we can see that Kubernetes has updated our config map within this container to have joy, sadness, anger, fear, and disgust. Those are the emotions that we have within inside out. So let's just have a look back on our website. And we'll go back and let's just see what's happened here. Let's have a look at our build status. Unable to open file. Well, that sucks. But, I was expecting to see that. I hopefully this, yeah, that's for the offcuts. I was expecting to see that everything's running perfectly right now, but that's okay. We'll leave it like that. So let's talk about what we've just achieved there. We've used kubectl. And kubectl is a binary that allows us to connect to the Kubernetes API server. So if you're new to Kubernetes, Kubernetes just uses best practice. It's just got a RESTful endpoint as an API server. So when we're running these commands to get, edit, we could use apply, create, these things. It's all just connecting to this API server. The main thing to be aware of is that within Kubernetes, everything should go via the API server. And this is what we call our master. So that's also what we call the control plane. In here, we've got things that are called the scheduler. So the scheduler runs our workloads. We've got a controller manager, so that runs everything that we have within our cluster. But the core thing here is that we have etcd. Etcd is a key value store. And so what's happened is that we use kubectl and we use that service account that we found. And then we've gone and we've requested, we said, actually, we're going to add join sadness to this config map. And in updating it etcd, we've managed to misuse Kubernetes because now Kubernetes has said, well, I need to update these config maps over here. And so using kubelet, kubelet is what's running our containers for us across our estate, in our nodes, in our data plane. And incidentally, we've got kubeproxy here. Kubeproxy is what's allowing us to have that in DNS that we had earlier on. So interacting with the brain of Kubernetes. So everything goes via the API, as I just mentioned. There are three main binaries. There's kubectl. So kubectl, again, you don't have to use kubectl. You could just use kill if you wanted to, but kubectl is a binary that allows us to connect to our server, our API server. Kubelet is running on our data planes, on our control planes, on our nodes, and that's just running our workloads for us. Kubeadmin is a shout out just saying how you can create servers if you so wish. And that is what's just said there. So let's just go into our underlying technology as well for a moment. I'm going to try and give us some time. I think I'm just check on the time. Okay, we've got about 10 minutes left for questions. So just to do a bit of a background as well. So containerization didn't come from Docker. Docker had a great user experience. But what containers are Linux namespaces, Linux C groups, and system capabilities, as well as you could argue some secret source. Linux namespaces. This is what creates this, this concept of a sandbox environment, this isolation. So using Linux namespaces, we can create it so that the container believes that it's got its own file system. We can create a Linux namespace network, so then it believes that it's got its own network. These are what we utilize to be able to build that environment so that when we go into a container, it isn't the root of the machine. This is what it believes to be, as it just feels that it is its own machine, and it's only got access to the processes, which is another namespace, incidentally. That's why the container can only see its own processes. We've also got this concept of C groups. C group stands for control groups. Now, control groups are there to manage the noisy neighbor issue. So if we're running multiple processes on a machine, say that you've got your unique selling point for your business, and that's process, say, 1. And you're just like, right, use as much of the machine as you want. But then you've got an underlying process that isn't as important. So say that it just reduces the size of an image. So it's like, it's great, but it isn't business critical. So you might utilize C groups to ensure that the amount of CPU and memory that that process can use can be limited. So that if there is an issue within there, so if there's a bug or, well, and as we're talking about OWASP, well, if someone does exploit it, then it can only use so much CPU and memory. Now, this is a great way for us to be able to handle that. And so Linux namespaces and Linux C groups, they're not specific to containers. This is what containers use. This is the abstraction to be able to provide these environments. So yeah, namespaces limits how much you can see, and C groups limits how much you can access. And Brad Giesman, lovely, lovely person, has this great quote: "It's not a container escape, it's a process that wants to be free." So when we're looking within containers, and when I did the PS orgs earlier on, we only saw processes that were running within that container. If we ran that PS orgs on the machine that was running the containers, we'd be able to see them. And that's also just a great thing to have a look at in your own time. Right, so we've got a container breakout. Let's see if we can get this container breakout done now. So our config maps have been updated. Yes, and so and Penelope has been disconnected. That's okay. And the reason I say that's okay, because we prepared our attack here. So I just run this command again, and then if I go back to Penelope, I can see that a new shell has been assigned. So I can go on to session 2. And now I have a new shell available. Now, this is a new container that we have running. And so I don't have my aliases available to me anymore. So if I do kgetpods, k isn't found. That's because the disconnection that's happened, Kubernetes has updated this container that we're running behind the scenes. Again, we're a little bit short on time, so let me just show the end of this attack. Now, the important thing about this attack is that at this moment in time, we were able to interact with Kubernetes, and we kind of fixed something here. Again, for a CTF, this is all about us teaching and learning so that others can learn. But let's have a look. Let's do our mount command here. So I didn't have access to mounts, but if I do cat proc 1 mounts, so I can see something in here called Docker. I can see a couple of things in here called Docker, but at the bottom, I can see run sock.docker. So incidentally, it's usually called docker.sock, but when we did this CTF, this was part of our competition mode, so we wanted to make it a little bit more difficult and just be a bit annoying in that manner. So if I got a Docker socket available, if I run Docker, I've got the binary available. But if I do a Docker PS, I can't connect onto the Docker daemon because, as we can see there, it's attempting to find the Docker daemon on var run docker.sock. This is Linux. So in Linux, everything is a file. The docker.sock is an API endpoint for the daemon that the Docker client is trying to connect onto. So if we just have a look here again, so actually what we want to connect this onto is run sock.docker, because I feel like I'm running out of energy at the moment, so I'm just going to do a copy paste again. So in passing across, let's just see this command again: docker -host unix var run socket.doc and ps. So if I run that, it's showing me all the containers that we have running on this virtual machine at this moment in time. Now, why might we have that? Well, just remember that this is still unable to open the file apparently. Oh, there we go. Clunk. The machine is now perfectly balanced and running properly. All sockets are now neatly aligned. So that sockets about being neatly aligned is trying to allude to this concept of the Docker socket. So this is a memory CI/CD build system. And what we used to see is that people would incorporate the Docker socket into their CI/CD build system, because previously you had to connect onto a Docker socket to be able to build images, or you might be looking to run them as well as part of your process. Not ideal. There's other tools available. So you don't need to give access to a Docker socket to be able to do this. Equally, as a runtime, there are other runtimes available too. Again, alluding to the previous talk, threat modeling, great place to be able to look at this as to which container runtime you should be using and at what basis. So on that, let's just look at our Docker socket again. Now, so if I can look at what we have running, then potentially I can also run something ourselves. So I'm just creating an alias for d docker. So now I can just run d and run this command. And just to say, we should be done in about 5 minutes as well, just to make sure that everyone is cool on the moderation front. I'm going to do d run. I'm going to run an interactive container, IT. It doesn't stand for interactive, but that's how I remember it. --rm means that once this container stops, when the process one within this container stops, then to stop the container. Now, --, privileged. If you're new to containers, privileged is the most dangerous flag in the whole of compute, was a quote by Andrew Martin. In talking about Linux namespaces a moment ago, what running as privileged does is it removes that. It removes that isolation. So that allows me access to, say, the host namespaces, so the IP addresses and so forth. The reason you might see privileged is if you've got developers who are looking to utilize, say, some hardware that's on the machine that's running the container. So say that you're doing some machine learning and you want to use a GPU. Within that container, the container has its namespace, so it doesn't have access to GPU. If we run it as privileged, then it's essentially running as root on the machine, so it can access it. The main takeaway here is least privilege. So we want to give it as little privilege as possible. Instead of giving a privileged parameter like this, you'd want to look at enabling capabilities, so system capabilities to be able to access it. So after the privileged flag, we've got -- process ID is equal to host. So we're attaching this container to the host process ID. And we're using Justin Cormack, who is the CTO at Docker now. Again, lovely person. And we're using their container that they've named nsenter1. So the image was wasn't able to be found locally. It's pulled it down, and now I have another terminal. So if I do an lsla, I can see I'm in another file system again. And you're like, well, yes, you're in another container. Obviously, there's a new file system that you're able to. But this is a process ID of host. And so now what I've done is if I do a ps_awks, I can see all the processes that are running on this machine. So now I've become root. I've become root of this machine. And that's important because I've gone from being in a position where I didn't have any access. I was within a container. We used our service account in kubectl to then be able to fix this pipeline that unlocked the Docker socket for us. And Docker, when we're running Docker, we're running it as root, and then that allows us to run containers as root. And so that's our point where we're able to pivot out from being a user without these, with least privilege to being root with everything. So yeah, and then within this, if we just have a look, and just to show you, again, please don't tell anyone else about the flag. If I cut out root, and then flag.txt, it's almost like I already knew where it was. That was our flag. So now I've shared it with you. The flag is essentially useless now. But the point here is that hopefully, as you've seen with this talk, you've gone from a basis of just having access to a website, which arguably it wasn't even working properly at the time. And we were able to find an exploit in there to be able to create a reverse shell. And we're creating a reverse shell. It allowed us to get into the system, and in getting to the system, we were able to then start peeking around. We had a look at the config maps. We remembered that Inside Out is an amazing movie. If you haven't seen it, I definitely recommend it for this weekend. As we updated the config map, because utilizing that service account and seeing what we had. In doing so, it created a Docker socket being available, which allowed us to connect onto the Docker socket and to be able to run a workload that we set as privileged, which allowed us to then gain access as root. So let's just tidy up on these slides, and then we've got some time for questions. So there we go. And what do we do? So we've used our fake ID to then say that we are now root, and we've ran a privileged container to be able to do that, pass through the process ID, and everything was good. So we did some attack diagrams as well for this. So we can see that our container within our pod was connecting to etcd. Well, actually, this should be via the API server. Updates, we'll add an issue. And then, as we can see here with data plane level, we created this reverse shell. We found the CI memories namespace. Again, this information, it's not leaking. We have this information available to us. There's other ways that we can find out as well, different namespaces. But in doing so, we were able to access etcd, and we had a look. And then finally, we ran this command. So if you are ever locked out of your machine and you've got Docker running on it and you're able to get in as a user, then this has saved numerous people in being able to access root again. Right, and there we go. So mitigations, defense in depth, don't connect Docker sockets into containers ideally. Look at, like, say, Builder or Calico. Calico. Oh, gosh, 5 more minutes. Look at utilizing the tools that are available to be able to build images without having to connect onto the Docker socket if required. If you do need to connect onto the Docker socket, then do a threat model. Have this as deep as you can. Don't have it publicly facing in these workloads. Yeah, we got a number of, so there's other things there about capabilities. So, we're coming to the final stretch. So just to say thank you to @JPTS_. So James is a pen tester at Control Plane. He helped build this scenario, gave a phenomenal talk at KubeCon. I keep saying everyone's lovely. I don't know how, but I'm surrounded by lovely people. So that's definitely someone to follow and watch, and their career is just going to go astronomical. And to that as well, I've got V as well. So V, we met at a conference, and they helped bring this talk up and make it bigger. So again, someone who is just phenomenal and someone I'd recommend to follow. And to that, I've done Tag the Planet. So these are just a couple of people. I've put myself in there, like, how self-indulgent of me. But these are some of the people that I've mentioned, but also these are some of the people that I follow personally to be able to keep an eye on the industry. Duffy from earlier on is Malorian. I think I pronounced that right. We had Brad Giesman. Yeah, so please have a look at those Twitter accounts if you want to keep up to date with those things. Other than that, I'll tell you what it's all about. It's all about punk rock. So thank you for your time. I tried to create this slide as a way to remind me of when I used to run Windows and when it all get a little bit static. But to that, thank you. Thank you for your time. I'm happy to take as many questions as we have in the next 5 minutes. And yeah.
All right. Thank you, Lewis. Awesome demo, by the way. Pretty cool to see. I see no questions in the Q&A, but I've got some for you. So what are the common pitfalls when we speak about Kubernetes security in general?
I would, it's misconfiguration. And so Kubernetes is, it's no longer the bright young whippersnapper that it used to be, but it is constantly evolving. And what we see is that when clusters are created, so previously, for example, when you created a cluster for the first time, it would create a Kubernetes dashboard. That dashboard gave you access as cluster admin. So it gave you this beautiful UI. But what happened was some people they created a cluster. It's the first time creating a cluster. And that's important. Like, people need to be able to build things to be able to learn. But they were creating them publicly facing. And so people were able to gain access to these dashboards. And again, similar attack path in that you could run a privileged a container within a pod, and then you've got access to the nodes. There's also a company who make some electric cars within America who had an attack happen there. Someone got access to a Kubernetes dashboard, which essentially gave access to their S3 bucket keys. And then there's crypto mining that was happening across the data plane as well. So I'd say it's misconfigurations. And I understand it's so simple for me to say misconfigurations and constantly say misconfigurations. I would definitely recommend the book, Hacking Kubernetes. But I'd also say as well, for people who are new to Kubernetes, Kubernetes is just another name built on years and years of core technologies. If you're looking to get started in Kubernetes, if you're coming from a networking background, if you're coming from, say, storage, if you're an app dev or so forth, focus on something that you can connect with, because you quite quickly learn that actually these things that like these acronyms and so forth are just built on best practices that you already know. As soon as you get that point where you're comfortable, then you're standing on the shoulders of giants, because then you see these best practices from everyone else. So yeah, I guess those are the core ones there. There's tools as well from companies like AppSecEU. So they've got Kubebench, for example, that can give you a score to say what's happening with your cluster. I'd still say today, though, that's a great starter, but pen testing is also best for this as well, to find out those aspects. And also, yeah, I would say there's companies now that are really focusing on service meshes. So there's companies like Isovalent, Tetrate. That's where it's also getting quite exciting for me, because as a network, it's a flat network, but now they're solving these problems with like TLS at rest and so forth, and it's just further building up security into our clusters.
Right, cool. Thanks for the information. Maybe one more question, because I see we only have 2 minutes left. And in the demo, you showed us the entry point injection with the reverse shell. Mm-hmm. What are other entry points that could cause damage to a Kubernetes environment?
Great question. Probably RBAC misconfigurations. So that service account. If in creating a cluster, you're giving people access to the API. So equally, having the API, the Kubernetes API server publicly available is a big no-no. Have it hidden behind a VPN or anything to ensure that you've got a level of trust there. But yeah, RBAC misconfigurations, looking at service accounts, insider attacks potentially. And by insider attacks, this is the basis of, so I gave a talk at KubeCon about threat modeling, and also after following this talk on threat modeling as well. Yeah, there are those issues where people can get leverage, and these service accounts, if gained access, as we showed there, once I spun up that privileged container, if it was publicly facing, then I could have just added my public key into the authorized keys, and then I could have SSH'd onto that node. In doing that, my next phase of the attack would be to kill that container and look at running it on another node. And before you know it, I've got SSH access to all the machines across the estate, and then it's essentially game over. Because again, like keep going on, I like to make things simple for me. I don't want to have to keep spinning up reverse shells to be able to gain access.
All right, cool, nice. So it's basically all about keeping least privilege and don't do misconfiguration.
I wish it was more exciting at times, but it's like, this is, like I said, it's just best practice. It's everything that we've been talking about today, yesterday, years gone by. It's continuing that practice, and yeah.
All right, thanks, Lewis.
Cool.
Then I will wrap up, and I want to thank you for this interesting session. So thank you, Lewis, and have a nice day.
And you. Cheers, Lars.
Bye-bye.